we have discussed energy stored in a capacitor. So today first we will discuss distribution of charge. So first we will discuss distribution of charge. Then we will discuss combination of capacitors. Combination of capacitors. Then we will discuss effect of dielectric. Effect of dielectric. So these three topics we are going to discuss in this class of the capacitors. So first let us see distribution of charge. Distribution of charge. Distribution of charge. In this, what we are going to discuss is, suppose we have like plates of the capacitor like this. Suppose we have two plates like this, one plate like this. So suppose these are two plates of a capacitor, and charge on each plate is like Q1 and Q2. So how charge will be distributed? What happens if you have two charge plates placed nearby? So distribution of charge takes place like this. In outer plate, charge is Q1 plus Q2 by 2. Here Q1 plus Q2 by 2. And inside it comes as Q1 minus Q2 by 2. And on this plate it comes as Q2 minus Q1 by 2. So this is the distribution of the plates. So we know in capacitor what happens. In capacitors, suppose Q1 equal to Q, then what Q2 becomes? Q2 is minus Q. We know that Q, this is the general case. This is the general case. But we know in capacitor, charge on plates is equal and opposite. So what will be charge on the first plate? We see that this charge will become 0 and this will become Q1 minus Q2. Means it will become plus and this will become Q. And similarly, this side is Q2 minus Q1. So it will become minus Q and this charge will become 0. So in capacitor, what happens? Because of equal and opposite charge, we are getting charge distribution is like this. This one is plus Q and inside it is minus. Understood my point? Any doubt in this? So this is happening in capacitor. We are getting equal and opposite charges on both the plates. And on outer plates, charges are 0. Now, when we talk about electric field, what happens to electric field? Electric field between the plates is from plus to minus. Electric field is like this, and it is in between the plates. Electric field on outside will be obviously zero, so no charge. So outside the plate, electric field will be zero. This is between the plates. Electric field will be, suppose its area is A, area of each plate is A, then due to first plate it is sigma by 2 epsilon naught, and due to second plate it is also sigma by 2 epsilon. Since electric field are due to each plate, electric field is sigma by 2 epsilon. Since electric field due to each plate is in same direction, so net electric field between the plates is sigma by epsilon. And their sigma is charge per unit area, so sigma by q. So this is the electric field between. Understood this one? How electric field is calculated between the plates? So it is always sigma by epsilon naught between the plates, and outside the plates electric field is zero. Understood it? Paper? Okay. So this is how charge is distributed between the plates. Now going to next thing, combinations of capacitors. So combination. We know generally there are two types of combination. First is series combination. In series combination, what happens? We know that capacitors are squared like this. Suppose we have three capacitors C1, C2, C3. So charge on each capacitor is same. Suppose we have charge on first capacitor is Q, then charge on each capacitor will be the same. Potential will be different. V1, V2. So the equivalent capacitance is given by this 1 by C square to, we know that 1 by C1 plus 1 by C2 plus 1 by C. And we know that V1. So if charge on each capacitor is Q, so you can write Q is equal to C1 V1. So from there you can calculate potential of first capacitor like this Q by C1. Similarly, we can calculate potential of second capacitor Q by C2 if we know the charge, and V3 will be Q by C2. So charge on each plate is safe. If there are two capacitors, if there are two capacitors in series, so we know that in series combination 1 by C will be equal to 1 by C1 plus C2. For two capacitors, 1 by C will be equal to 1 by C1 plus C2. And from here, we can get a result which we will remember directly. We will write it directly like C is equal to C1 C2 by C1 plus. So this is very helpful. Generally, for two capacitors, we directly write equivalent capacitance is equal to C equal to C1 C2 by C1 plus C. So this is how we calculate equivalent capacitance for two capacitors. So this formula is written here. C is equal to C1 C2 by C1 plus C. Getting my point? Now getting parallel combination. Parallel combination, what happens? Two capacitors are connected parallel to each other, like we have two capacitors C1 and C2. So their potential is same. Their potential is same. And in that case, we get equivalent capacitance C is equal to C1 plus C. Merely add. If there are n number of capacitors, we get C is equal to C1 plus C2 plus C3 and so on. Here potential will be same, charge will be different. The charge of one capacitor will be. So this is how we do for series and parallel. This is how we will learn the formula. The main we will learn the main concept while doing the question, how to solve combination of capacitors. So and the third type of combination will be mix of both, mixed combination. And question mostly will be asked from mixed combination. In mixed combination, we will have both series plus series plus. So in that case, we have to see according to the circuit diagram, we can apply series and parallel combination and we can solve the later. Getting my point? So understood till now? Any issue? Please ask. So now we will directly do the questions, NEET questions, so that we can apply these concepts in getting equivalent capacities. So let us see first. Then we will study effect of time. So first we can see little easier question. Okay. First see question number 39. First see question number 39. See question number 39. Go through this question 39. Let us understand the question. What it says. It says three capacitors, each of capacitance 4 microfarad, are to be connected in such a way that effective capacitance is 6 microfarad. So we have three 4 microfarad capacitors. We have three 4 microfarad capacitors. So these are three capacitors. Capacitance of each capacitor is 4 microfarad. Okay. So now what we have to do is we have to connect these capacitors such that we should get equivalent capacitance of 6 microfarad. Means we have to connect in such a way that we should get equivalent capacitance of 6 microfarad. So in the question, we have different options. So we will go by option, and then we will check which option is correct. So first, we will see option C. What it says is to connect them in parallel. So we know that in parallel capacitance is added. So if we connect them in parallel, what will happen? 4 plus 4 plus 4. We will get 12 microfarad. But we need 6 microfarad. So this is not possible. So C is not correct. We cannot connect in parallel. If we will connect in parallel, we will get 12 microfarad, but we need 6 microfarad. So C is not correct. Now see option B. What it says, connect them all in series. So we know that in series combination, what happens? If there are n number of capacitors, identical capacitance, then equivalent capacitance becomes 1 like if we have capacitance C and 3 capacitors in series, so what happens to the capacitance? It becomes C by 3. We know that 1 by C equal to 1 by C plus 1 by C plus 1 by C. So in series combination, what will happen? C series will be equal to, this is parallel, C by 3, and each capacitance is 4 microfarad. So we will get 4 by 3 microfarad in series combination, which is also not correct. We don't need 4 by 3. So B is also not correct. Now we left with two options, connecting two in parallel and one in series. And second option is connecting two in series and one in parallel. So only in mixed combination we can get 6 microfarad. So go by first option. What it says, according to first option, it says connect two in parallel. Like we can connect two capacitor in parallel, okay, and one in series. So according to this, it is saying connect two in parallel and one in series, like this. So we will check equivalent capacitance. These two are in parallel, so their equivalent capacitance will be 8 microfarad, and this is 4 microfarad. Sorry. And this is 4 microfarad. So these will become in series. So what we will get? 8 into 4 by 8 plus 4 means 32 by 12. So we are not getting 6. So this is also not correct. So the correct option is D. A is also not correct. We will check in D we are getting 6 or not. So what it is said in D, connecting 2 in series and 1 in parallel. According to this, it says that connect 2 in series and then 1 in parallel. So it means connecting 2 in series and 1 in parallel, like this. So we will also check this combination. So these two capacitors are in series Means what will be equivalent capacitance? 4 by 2. It means 2, and 2 is in parallel with 4. So we will get 4 plus 2 means 6 microfarad. So the correct combination is D. Understood this one? Or we have to check the options? So the correct option is D. So this is how we should proceed in such questions. This was NEET 2003 question. Okay. Moving to next question. Now see question number 46. This is also kind of combination. So we will see question number 46. This is in 1999. See this question. So we have to, what is the effective capacitance between point X and Y? So what we have to do in such cases? So in such cases, what we have to do is, these type of questions are frequently asked, and you cannot basically, in NEET exam, merely they will not ask what is the equivalent capacitance of series and parallel. They will give question with a twist. So here we have, by seeing this figure, we cannot say capacitors are in series or parallel. So what we have to do is, to solve such question, we'll select point, like we have different points. Here we have point A, we have point C, we have point B, and we have point D. So what I will do, I will write the point. I will write the points here, like point A, write point A, then point B, then I will write point C, then I will write point D. Randomly, I will write these 4 points, A, B, C, and D. Now we will identify the capacitors connected between these 2 points, these different points. Like if you see, between A and C, we have this capacitor. So connect the capacitor between A and C, like this. What is its capacitance? 6 microfarad. So it is 6 microfarad. Now see the points A and B. So we have one capacitor connected between A and B, 6 microfarad. So again connect capacitor like this. Between A and B we have 6 microfarad. Then what we have to do? C between B and D, again you have 6 microfarad. So between B and D we also have a 6 microfarad. Okay. Again, if you see between C and D, we have C and B. Between C and B, we also have a capacitor that is 20 microfarad. Between C and B, we also have a capacitor that is 20 microfarad. And also between C and D, we have 6 microfarad. So there are total 5 capacitors. You can count 1, 2, 3, 4, 5. So here also we have 5 capacitors. So all are arranged. So if you see this structure, basically it is a Wheatstone bridge. So first I will separately explaining with stone bridge little bit, then we will solve this one. So I am holding this till here, then I will explain you first with stone bridge. Then we will get back to the question. You already have some idea, I think, about what is stone bridge, but I will give you a thing. So with stone bridge. With stone bridge. You may have read in, I think, current electricity also. So what is with stone bridge? It is a basically combination of capacitors. Same as the in current electricity, we can also have with stone bridge in combination of capacitors. So if four capacitors are connected like this, like we have capacitors connected A, B, C, D, and it is connected to a battery. And suppose this capacitor is C1, C2, C3, C4. And this capacitor is C5. So this combination is known as Wheatstone bridge. And what happens? Balance condition. Generally, what we study balance condition. Balance condition. What when it happens? If C1, C3, C1 into C3. Generally, we take ratio and we get confused. So what we should do? We should multiply C1 and C3. C1 into C3 and then multiply C2 and C4. So if we have the value such that C1 into C3 is equal to C2 into C4. So in that case, it is known as balance condition. Don't remember the ratio. In that case, we get confused. We should take C1 by C2 or C2 by C3. So merely you should remember that opposite side capacitors multiplication, if that is equal, then the capacitor is known as balanced capacitor. And in that case, we can remove C5. And in that case, we can remove C5. And what happens? If C5 is removed, then we get a structure like this. C5 is removed, we get, then we have no issue. We can identify parallel and series combination. So these are like C1, C2, right? C3, C4. Then we don't have any issue because now we can easily connect. Since C5 is removed, so now we can easily identify which capacitors are in series and which are in parallel. You know that these two are in series, so their capacitance will be C1, C2 by C1 plus C2. And again, these capacitors also are in series, so their capacitance will be C4, C3 by C4 plus C3. Then these two are in parallel. So what we will get? Net capacitance we will get C1, C2 by C1 plus C2 plus, since these two equivalent capacitors are in parallel, so C3, C4 by C3 plus C. Getting my point till now? Any doubt, please ask. So now we can get back to the question here. If you see here, the product of opposite capacitors are equal. You see here, the product of opposite capacitors are equal. If you see the product of this C1, this is 36. And again, if you see their product, this is also 36. It means this combination is balanced. This is balanced with stone bridge. So we can remove 20. We can remove 25. This can be removed. This can be removed. It is removed, no issue. The net structure we will get like this. We will get it like this, 6 microfarad. Then this 6, this is 6. Again here also we will get 6, 6 and 6. So we will get structure like this, and 6 and 6 are 3, so we will get 3. Here also we will get 3. So what will be net capacitance? These are in parallel, 6. Understood this one? Okay. So this is how we should proceed with such question. All right. So this was second type of questions. We have discussed first type of questions also. So this is balance with stone bridge case. Now see this question number 48. Easy question. Go through question number 48. Go through this question number 48. So here we have 4 capacitors are connected as shown in the figure. Then we have to find the charge on each capacitor. So try it. You are getting D. Okay, B. So let us check. We have to find charge on each capacitor. The four capacitors are connected as shown in figure. The DC voltmeter reads 20 volts. Okay, the charge on each plate. So very simple, I think. The charge on each plate of capacitor is. So from figure, we can see that the potential of this capacitor will be same as 200 volt. So potential of this capacitor will also be 200 volt. Both are in parallel. So we know that Q is equal to CV. So from there we can calculate the charge. Capacitance is 25 microfarad, 25 into 10 power minus 6, and voltage is 1. So from there we get 5000 into 10 to the power minus 6. It means 5 into 10 to the power minus 3. The charge of each plate of capacitor is. So here charge on each plate of left side capacitor is 5 into 10 power minus 3 microcoulomb. 5 into 10 power minus 3 coulomb. What about these capacitors? If you see here, all are in parallel, right? All are basically connected in parallel. The charge on each capacitor will be same, and potential will be of each capacitor will be same. So here charge of each capacitor will also will be same. Since capacitors are identical, then the correct answer will be you are right. If someone asks you equivalent capacitance, so what will be equivalent capacitance? All are in parallel, so 4 into 25. 100 microfarad will be equivalent capacitance. These all capacitors are basically in parallel. If you see, getting my point? Okay. So this is how we calculate capacitance. Moving to the next type of questions. Now we will see the next concept. Then we will do some questions. I will give you some more questions based on series and parallel capacitor in the assignment. So now getting the next concept, that is the third concept, that is effect of dielectric. So let us discuss effect of dielectric, and then we will do some questions on that. Effect of dielectric. What happens if a capacitor is completely filled with a dielectric? Like if this is a capacitor and it is completely filled with a dielectric of dielectric constant K. So suppose initially the capacitor was like this, and in the capacitor there was air, and its capacitance was C naught. Now this is filled with a dielectric of dielectric constant K. So the new capacitance will be what happens? It will become K times. It will become K C naught. If it is completely filled with dielectric, if it is completely filled. Sometimes it may be partially filled. So it is only for completely filled. Sometimes what happens? Capacitor is partially filled. So in that case, what happens? Like you have a capacitor, and suppose I partially filled it with a dielectric. I filled it with a like some dielectric like this. Suppose its dielectric constant is K and its thickness is T. I don't fill it completely, I just fill it partially. And suppose original distance is D and area is A. So what will happen now to the capacitance? It will become like this. C is equal to epsilon naught A by D minus T plus T by K. So the capacitance, you have to remember this formula. If we fill the capacitor with a dielectric of thickness T, so in that case, the formula is this epsilon naught A by D minus T plus T by K. If T is equal to D, in that case, you will get this. T is equal to D, in that case, you will get this. Understood this one? Any doubt? All right. So if there are number of, we can also extend it to number of dielectrics. If you insert any number of dielectrics, the same result can be extended. If like you have put many number of dielectric, like dielectric having thickness T1 cap, dielectric constant K1, then another dielectric of thickness T2, dielectric constant K2, and so on. Tn, K. So same result can be extended. Like this is one plate. So the same result can be extended, and in this case capacitance will be epsilon naught A by, then what we will like same result epsilon naught D minus, in place of T we will like T1 plus T2 and so on, plus T1 by K1 plus T2 by K2 and so on, Tn by K. So the same result can be extended for n number of dielectrics. Understood this one? Rifat, understood this one? How we got this? Okay. Now what happens? We will see some phenomena like uh, Like if you have a capacitor, there are two cases also. Case one, dielectric without battery. Dielectric without battery. What it means? It means suppose you have a capacitor and it is fully charged. It is not connected to battery, without battery. Suppose this is a capacitor fully charged. Charge is Q naught. And what we do? We insert a dielectric. Actually, we have charged the capacitor fully and remove the battery. Now what happens? We insert a dielectric. Now we inserted the dielectric. So in that case, what will happen? We have inserted the dielectric of dielectric constant. So here what will happen? What the things will change and what will remain same? Charge will remain same. We know that charge is conserved. So charge will remain same. You know, charge will remain same. Charge is not going to change. So charge will remain same. If potential was V naught, potential will reduce. New potential will become V naught by K. Electric field will reduce since potential is reducing. Electric field become E naught by K, and capacitance will increase. We know that capacitance C will become Kc naught. So these things, potential obviously will decrease since medium is not dielectric. Electric field will decrease. Charge will remain same. Understood this one? So whenever we insert the dielectric without battery, battery is not connected to the capacitor. Potential decreases, electric field between the plates decreases, capacitance increases, charge remains same. Also, what happens to energy? If initial energy was, all the initial quantity was like V naught, V naught. Suppose initial, what will happen to energy? We know that energy is half CV square, or energy is also like Q square by 2C. So charge is same and capacitance becomes C. So it will be Q naught square by 2C. C is becomes Kc naught. So basically what will happen? Energy will also decreases. U will become U naught by K. U naught square by 2 Kc naught. So Q naught square by 2C naught is U naught. So energy will also decrease. Getting my point? Understood this one? So potential will decrease, electric field will decrease, energy will decrease. The second case is we can insert dielectric with battery. The second case is case 2, dielectric with battery. Like we have a fully charged capacitor and battery is connected. Battery is not disconnected. Battery is connected and we have inserted a dielectric. Battery remains connected and we have inserted a dielectric of dielectric constant. Suppose potential of the battery is V or V naught. So what will happen? Here potential in first case charge was same. In first case, if you see charge was same, here potential will remain same. Since battery is connected, so potential will remain same. Potential will remain same, and it will be equal to V naught. Charge will decrease, and it will be equal to Q naught by K. Electric field will remain same. Since potential is same, electric field will also be remain same, and it will be equal to E naught, and capacitance will increase. Capacitance always increases, will become Kc naught. Energy, we will see what will happen to energy. Energy is half Cv square, we know. So here potential remains same, and capacitance becomes Kc naught, right? So half Kc naught V square. So if you see, energy becomes K times, energy increases. Energy becomes K times, what is energy? Half Cv naught square, potential remains same, capacitance increases. So half Kc naught V naught square, so energy will become Ku. Getting my point? So understood this one? All right. So based on these two concepts, now we are going to do some questions so that you can get concept clarity, more concept. So getting back to the questions. You can see this question. Basically, this is easy question. See, you can see question number. So this is in two page. Question number 31. Let's see question number 31. So go through this question. One option is also there. So go through this question. It says two identical dielectric slabs of dielectric constant K1 K2 are inserted between the plates of a panel capacitor shown in here. So shown in. So we have to find electric field from plate P. Electric field. Here we should have electric field. Oh, this one is missing. This one. Read from this one. Will be better. Electric field. We have to find the variation of electric field between the plates with distance. This question is NEET 2014 question. Actually, this is very easy question. It seems to be lengthy, but it is actually easy. So we have to find the variation of electric field between the plates with the distance d. Okay, let us see. Here what will happen? We have inserted the dielectric. We know that when we insert a dielectric, what happens? Electric field decreases. What happens? Electric field should decrease. So now you see the options. Option D is not here. You can see here option D. So electric field should decrease, right? So option D is not possible. Okay, here electric field remains constant. So D is not possible. So now go to option A, B, and C. If you insert a dielectric, electric field must decrease. So electric field cannot increase. So here if you see option A cannot be true, here electric field increases. When we insert a dielectric, electric field should decrease. Now you can directly answer the question by removing the option. You can see here also. If there is an increase, you should remove. Here also electric field increases. So it is also not possible. So the correct answer should be C. Electric field must decrease. Here we have dielectric constant is different. What happens to the electric field? E becomes E naught by K. So their values will be different since dielectric constants are different, but electric field must decrease. So the correct answer should be C. Understood my point? So actually this looks like difficult question, but this is very easy question. Only the thing we should remember is if there is a dielectric, electric field should decrease. So we can remove those options which having increase. Without any calculation, we can answer this. All option A, B cannot be true, since in A electric field increases. In B also, if you see this portion, electric field increases, so it cannot be true. In option D also, if you see here, in D also electric field remains constant, so D also not possible. So only the remaining option C can be correct option. So this is how you should solve this question. Okay. Now see question number 34. See this question number 34. Where is the question? Go through this question number 34 and tell me the answer. NEET 2010 question. Very easy question. Correct. It should decrease same as dielectric. If dielectric coil will act as a dielectric, and if dielectric is inserted between the plates, we know that electric field decreases. So electric field should be E is equal to E naught by A. So this is how electric field is calculated, and it should decrease. Let's do this one. Okay. Now we will do there is another term, force between the plates of a capacitor. So go through question number 30. I will do it by question. Go through question number 30. That is basically very easy. It is based on force between the plates of a capacitor. So directly you can remember force between the plates of a capacitor. Okay, Q square by. Actually, force is Q square by 2 epsilon naught. So how we calculate forces? Yeah, I think your answer is correct. What is force is? How we calculate force? Force. We have two capacitors. Suppose we have capacitor plates as having area A. So what we have to do? We have to consider when we finding force on a plate, we have to consider electric field due to one plate only. We know that electric field due to one plate is sigma by 2 epsilon naught, right? So if you want to calculate force on this, that will be charge into electric field. So charge into electric field is sigma by 2 epsilon naught. So it can be done like this, and Q sigma is Q by A by 2 epsilon naught. So force between the plates you can directly remember Q square by 2 epsilon naught. This is the force between the plates. Now in the question, we know that Q is equal to CV, so you can put it like this. C is the capacitance. So now put the values. Force is Q square by 2 epsilon naught. Now put the values. Q is CV, so C square V square by 2 epsilon naught. C square V square by 2 epsilon naught. So the correct answer is, and now you can put the value of capacitance also. C is epsilon naught A by D. So or you can also put it like this. You have to answer in terms of D, right? So from you can put the value of A epsilon naught. C is equal to epsilon naught. C is equal to epsilon naught A by D. So epsilon naught A will be, from here you can write epsilon naught A equal to CD. So if you put the value C square V square by 2 CD, so C and C will be cancelled out. You will get CV square by 2D, right? So correct option is A. A is correct option. Understood this one? All right. Now do the last question, that is question number 29. I will take its screenshot so that you can better. Question number 29. So go through this question number 29. This is NEET 2015 question. Are you doing it? Okay. You're getting answer C. I think your answer is right. So, as discussed, what it says, if you see the question, a parallel plate air capacitor is capacitance C is connected to a cell of EMF wave and that's disconnected. So, actually, basically, this is the first condition, right? You see, this is basically this condition. First, it is charged, and then battery is disconnected. So we know that what happens, capacitance increases, and already I told you that charge remains same, capacitance increases, voltage decreases, electric field decreases, and energy decreases. So if you see here question, we have to find the incorrect one. So directly we can say that charge on capacitance not, this is not correct. So this is your right answer. No need to study other questions. If you try to solve in instantly, just see the option C. It is not correct, so our correct answer is C. No need to go through option A, B, and D. But for the sake of knowledge, if we can go through this, the energy stored in the capacitor decreases K time. We already know that U is equal to U naught by K. So this is true. So this is true. The change in energy, yes, delta U, what will happen? U is equal to U naught minus U naught by K. So it will be equal to U naught 1 minus 1 by K, and we know that what is U naught? Half CV square. So half CV square 1 minus 1 by K. So this is also true. Option B is also true. Option A is also true. And if you see the potential difference between the plate, yes, it is correct. We know that V is equal to V naught. So A, B, and D are correct. C is incorrect, but here we have asked incorrect. So this will become correct choice. Getting my point? All right. So this is how we should solve such type of question. Now last but not the least, we'll solve one more question and we will end up class for capacitor and capacitor. Mostly such type of questions are asked in NEET, not much more difficult than this. You can see this question quickly. Question number 28, or go through question number 28. This is NEET 2016 question. Are you solving it? So what this question says, it says that the capacitor, first it is charged through this point, and this point is shifted to this. So we have to find the percentage of its energy dissipated is. So basically we have to find the change in energy. So if we see initial energy, what is that? Half CV square. So the potential is like this. Capacitance is 2 microfarad and potential is V. If it is shifted to this position, what will happen? It is fully charged. So what will happen is the potential uh, will get, or first we have to see the charge. Charge will get redistributed between the capacitors. So what you have to do, you have to equate initial charge and final charge. Initial charge was 2 into V, and the final charge 2 plus 8 into V dash. So from here we will get common potential V dash to V upon 10, right? So it will be V upon 5. So their potential becomes V upon 5. So now final energy will be U final will be half. Total capacitance is 10 microfarad and potential is V naught square is V square by 25. So the percentage you have to find, basically you have to find delta U upon U. So the change in energy, what is change in energy? And if you see this energy, how much it is? It is basically, if you see V square by 5, and this is actually V square. So the change in energy upon initial energy, and V square minus V square by 5 upon initial energy was V square. So you get 1 minus 1 by 5 upon 1. It means 4 upon 5. And 4 upon 5 means